Unit 1B, Lesson 4. This lesson aligns with 6.5, 9.4, and 9.5 in your textbooks. There's two standards in this lesson. The first one, rewrite simple rational expressions in different forms. Write a of x divided by b of x in the form q of x plus r of x divided by b of x, where a of x, b of x, q of x, and r of x are polynomials with degree of r of x less than the degree of b of x, using inspection, long division, or for more complicated examples, a computer algebra system. We're going to focus on long division and synthetic division in this lesson. The second standard, understand that rational expressions form a system analogous to the rational numbers closed under addition, subtraction, multiplication, and division by a non-zero rational expression. Then we're going to add, subtract, multiply, and divide rational expressions. A few questions that you need to think about and be able to answer by the end of this lesson. First one, what conditions must be met in order to use synthetic division? Second one, what conditions must be met in order to add or subtract rational expressions? And the last one, explain what is meant by rational expressions being closed under the operations of addition, subtraction, multiplication, and division. First example, we want to divide these two polynomials. We have x to the fourth plus 2x squared minus x plus 5 divided by x squared minus x plus 1. We have to use long division in this case because we cannot use synthetic division. We can't use synthetic division because we're not dividing by a linear binomial. So how we're going to set this up, underneath our division box, this is our dividend. Outside is the divisor, what we're dividing by. Okay, we're going through the same process you used when you first learned long division. Okay, it's going to be a little more complicated because we're using polynomials, but it's the same process. Also notice when I wrote my dividend, I have to have a place value for the x cubed term that we do not have. It helps to keep things organized. So whenever you're missing a term in standard form, make sure you account for that by adding a 0 x raised to whatever power. First thing, I'm looking at my divisor, x squared. I want to determine what do I have to multiply by x squared to get x to the fourth. Well, I have to multiply x squared by x squared to get x to the fourth. So I'm writing that up here. The reason I put it over there, I want to line up like terms vertically. Helps to keep things organized. Now I have to take this x squared and multiply it by all three terms in my divisor. So x squared times x squared is x to the fourth. X squared times negative x is minus x cubed. X squared times 1 is x squared. And now I'm putting parentheses around this because I'm subtracting that whole quantity. So x to the fourth minus x to the fourth is 0. 0x cubed minus a negative x cubed is a positive x cubed. Well, cubed. And then 2x squared minus x squared is a positive x squared. And then I can bring down what I have left. Next, we have to repeat that process. I'm looking at my x squared in my divisor. What do I have to multiply this by to get x cubed? Well, I have to multiply x squared by x to get x cubed. So I write that up top. X times x squared is x cubed. X times negative x is minus x squared. And then, minus x squared. And then x times 1 is positive x. Again, I'm going to go through, put parentheses around here because I'm subtracting this whole quantity. Add vertically now, x cubed minus x cubed is 0. X squared minus a negative x squared is 2x squared. And then negative x minus x is negative 2x. And then I bring down my plus 5. Again, we're going to repeat the same process. I need to take my x squared in my divisor, and what do I have to multiply that by to get 2x squared? I have to multiply by a positive 2. So now I take my 2 times x squared, I get 2x squared. 2 times negative x minus 2x, and then 2 times 1 plus 2. Again, put parentheses because we're subtracting this whole quantity. 2x squared minus 2x squared is 0. Negative 2x plus 2x is 0. 5 minus 2, we get a positive 3. So if I'm looking at my divisor, what can I multiply by x squared to get 3? Okay, we can't multiply anything by that. So 3 becomes our remainder, plus 3 over our divisor, which was x squared minus x plus 1. So here was my a of x, here's my b of x. This portion is q of x, the quotient, and this portion is r of x, the remainder. Okay, so we have our remainder, we had our quotient q of x, and we started with a of x divided by b of x. Okay, so using polynomial long division to divide two polynomials. In this example, we're taking x cubed minus x squared minus 2x plus 8 and dividing by x minus 1. In this case, we're going to use synthetic division. We can use synthetic division because we're dividing by x minus 1, which is a linear binomial. So to use synthetic division, we're taking the coefficients of our original polynomial a of x. We list those up here. We take the k value of b of x, what we're dividing by, that goes outside the box. First step, bring down the 1. 1 times 1 is 1. Add vertically, multiply across, 0. Add vertically, multiply across, negative 2. We get a remainder of 6. Okay, so now we have to figure out how to write this. If we started with an x cubed and we're dividing by an x, that means this is going to be an x squared. So we have a 1x squared. We have no x term. We have minus 2. And then plus 6 over our divisor, which was x minus 1. This is our remainder. We always write our remainder divided by the divisor, what we're dividing by. So again, we have the quotient, q of x, and we have the remainder, r of x. We started with a of x and b of x. Again, we could use synthetic division in this case because we were dividing by a linear binomial. Next, we're going to multiply or divide rational expressions. A rational expression is simply a polynomial divided by a polynomial. So on the left side over here, we have a rational expression. We have a polynomial divided by a polynomial. We have another rational expression, a polynomial divided by a polynomial. When we multiply or divide these rational expressions, what we're going to do, we're going to look at every numerator, every denominator, and try to factor those out. The reason we're going to factor them, we're going to look, are there any factors in the numerator that are the same in the denominator that we can simplify out. So looking at this problem, if we have 4x minus 4x squared, can I factor that? Well, both those terms have a 4x in common, so I'm bringing a 4x out in front. I'll be left with 1 minus x. Now I want to factor the denominator, x squared plus 2x minus 3. So factors of negative 3 that when I add together give me a positive 2. This will be x plus 3 times x minus 1. Then I'm multiplying. Now I want to factor the numerator, x squared plus x minus 6. So factors of negative 6 that when I add together give me a positive 1. This will be x plus 3 times x minus 2. All divided by 4x, cannot simplify. Now I'm looking at numerator and denominator. There are some things that we can simplify out. I have a 4x in the numerator, a 4x in the denominator. I have x plus 3 in the denominator and x plus 3 in the numerator. and we have to be a little creative at this point. Okay, so let's just write out what we're left with first before we try to simplify any further. This is equal to 1 minus x times x minus 2, all divided by x minus 1. Okay, since we're multiplying, we multiply numerator times numerator, denominator times denominator, so we can write this as one fraction. If we have 1 minus x and x minus 1, those are very similar. What we can do to this numerator is factor out a negative 1. So if I take a negative 1 out of this numerator, it's going to change the sign on everything that follows. So this becomes negative 1 plus x, and now I have still an x minus 2, all divided by x minus 1. The reason we factored a negative 1 out, if you look at this term in the numerator, if I rearrange these terms, that's going to be x minus 1. So it simplifies with numerator and denominator. Now all we're left with, if I distribute this negative 1 through, is negative x plus 2. Starting with a fairly complicated problem, a rational expression times a rational expression, factor those out, simplified, canceled out like factors, we end up with negative x plus 2. Next problem, going to be very similar except we're dividing two rational expressions. If we're dividing by a rational expression, we can change it to multiplication. All we have to do is multiply by the reciprocal. So we change this from division to multiplication by multiplying by the reciprocal, meaning we switch numerator and denominator. Now this is the same type of problem we just went through. We want to go through, factor all the numerators and denominators, see if there's any factors that are in common that we can simplify out. So we have 5x divided by 3x minus 12, that has a 3 in common. This is 3 times x minus 4, multiplied by, looking at x squared minus 6x plus 8, that factors into x minus 4 times x minus 2. Now looking at this denominator, we have x squared minus 2x. Those have an x in common. So that's x, left with x minus 2. Now looking at the numerator and denominator, take out any like factors. X minus 4, x minus 4, x minus 2, x minus 2. We have a factor of x and a factor of x. So all we're left with is 5 in the numerator and 3 in the denominator. Again, starting with a fairly complicated problem, a rational expression divided by a rational expression. If it's division, we multiply by the reciprocal, factor out, cancel out any like factors, we're left with 5/3. Now we're going to work with adding and subtracting rational expressions. Just like we add or subtract rational numbers, we have to have a common denominator. So in this first example, 3 divided by 2x plus 7 over 2x, we're fortunate because the denominators are the same. So all we have to do is combine the numerators. 3 plus 7 gives us 10 over 2x, which we can simplify. 10 divided by 2 is 5 over 1, so we end up with 5 over x. So when adding or subtracting rational expressions, we need to make sure we have a common denominator. This next problem, we have x plus 1 divided by the quantity x squared plus 6x plus 9 minus 1 divided by the quantity x squared minus 9. This one's a little more complicated because we do not have a common denominator. So the first thing we need to do is find the common denominator, and we're going to do that by factoring out the denominators. So I went ahead and factored out the denominators. We have x plus 1 over x plus 3 times x plus 3 minus 1 over x plus 3 times x minus 3. What we need to do is find the least common denominator. If we look at this first denominator, we have 2 factors of x plus 3. So in the end, our denominator is going to have 2 factors of x plus 3. So over here, I'm going to write that, x plus 3, x plus 3. If we look at the denominator on the right, we already have a factor of x plus 3, but we also need a factor of x minus 3. So over here, I need to add that x minus 3 factor. So what we're going to do with each of these individual fractions, this first one, if I look, I have both factors of x plus 3, but I'm missing the factor of x minus 3. So I need to multiply the numerator and denominator by that factor of x minus 3. If I look at this second fraction, I need to multiply by x plus 3 over x plus 3 because I'm missing that second factor of x plus 3. So what we're going to have to do next is FOIL and multiply out the numerators. We're going to leave the denominators in factored form. The reason we're going to do that is because when we simplify the numerators, we're going to try to factor that again and then see if anything will simplify with the denominator. So always leave the denominators in factored form. If we FOIL out this numerator, x times x, we have x squared, negative 3x plus x minus 2x, and then minus 3. That's all going to be divided by the same denominator, which is x plus 3 quantity squared times x minus 3. Okay, and now if we look, we subtract, we have to make sure we distribute this negative sign to both terms. So minus x minus 3. Combine like terms in the numerator, x squared minus 3x minus 6, all divided by x plus 3 quantity squared and x minus 3. Remember, it's x plus 3 quantity squared because we had two factors of x plus 3. Now we would want to look, is there any way we can factor this numerator? In this case, there isn't, so this is our end result. We took these two rational expressions, subtracted them. We had to first find a common denominator. Once we did that, multiply out the numerators, leave the denominators in factored form, and we get our simplified answer. So whether we add, subtract, multiply, or divide two or more rational expressions, our answer, our result, is going to be a rational expression as well. So that's why they say rational expressions are analogous to rational numbers, because if we combine them using any four of those operations, our result will still be a rational expression. Make sure you go through and are able to answer these three questions. Okay, we're going to discuss these in class. In this lesson, we talked about these two standards. We used long division and synthetic division to divide two polynomials. We got a quotient and a remainder. And then we went through and used operations on rational expressions. We added, subtracted, multiplied, and divided.